All right, so those are the basic mechanics of our hypothesis test, the phantoms. We'll do variations on this, but you're still using phantoms for the next several weeks. What's going to change? They're going to be slightly different conditions that we'll expect, depending on the type of test that we're doing. And they're going to be slightly different mechanics to the test, depending on which test that we're doing. But it's the same basic idea every time. We're still going to write a null hypothesis, which is nothing interesting is going on. We're going to write an alternative hypothesis, which is usually what it is that we're looking for. And then we're going to run our test and hope for a small p-value. And again, by small, we mean less than whatever our alpha level is. And what is that alpha level? If no alpha level is defined, what is that critical value that we talk about? 0.05. I saw Ellie mouth it. I'm getting better at reading lips. Yeah, 0.05. So if p is less than 0.05, generally we're okay unless a different alpha level is indicated specifically by the researcher or by the problem. Okay? So usually if my alpha is less than 0.05, we are really going to be in good shape. Oh, by the way, got another friend to add to our thing. This is the sassy elf. The sassy elf makes messes of things, and I came in today and there was a note that I needed to go. There was an emergency in the tech booth, and I knew what the problem was. The elf had food and beverages in the tech booth. There were candy and chips and pizza and sodas all over the booth. He is a very naughty elf. Very naughty elf. But he's going to sit up here for the moment. I better not put that there. That would be potentially inappropriate. If I can get him to stay elf. There we go. All right, so there, one more festive thing to look at. So anyway, that's what we're doing. Oh, got a spinning wheel already. That's a good sign. So we want to go back to slide 1 and actually perform our test. And honestly, today is basically going to be this and one more example, and that's all we're doing today. So if we look at this, the Consumer Product Safety Commission claimed at least 90% of all American homes have at least one smoke detector. A city's fire department has been running a public safety campaign about smoke detectors consisting of posters, billboards, ads, blah, blah, blah. City wonders if this concerted effort has raised the local level above the 90% national rate. Building inspectors visit 400 randomly selected homes, find 376 have smoke detectors. This is strong evidence that the local rate is higher than the national rate. So P. So we're going to run a full phantoms here. P. State the parameter is the local rate of smoke alarm use higher. This real big lag here. I don't know if you notice, but I'm just kind of writing on blank areas, and I'm not sure what it looks like. Than the 90% national average. Okay, so there we go. Okay, that's what I want to. That's basically what I want to check out. H. Okay, this is where I do my hypothesis. I'm going to do two hypotheses: my H naught and my HA. And we talked about this yesterday. Okay, P, my H naught, P, not P hat, but P, P of SD. We're going to put a little. We did this yesterday. P of SD equals proportion of homes with working smoke detectors. Okay? What's my null hypothesis? P of SD what? My null hypothesis is always nothing interesting is going on. So what would the proportion of homes with smoke detectors be if everything was status quo? You can say it or you can put it in chat. I don't know why people are so afraid of talking sometimes. .90, yes. And my alternative hypothesis, that which I'm hoping to be able to prove, is it less than, greater than, or not equal to .90? So I guess that's the question. Is it going to be less than .0, greater than .0, or not equal to? In my P, stating my parameters, I said what I want it to be. Is it higher than the 90% average, so therefore greater than? Yes. Okay. A, assumptions and conditions. Okay. Independence. It is reasonable to assume that each home selected is independent. Random condition. Okay. Random condition stated in prompt. Okay. 10%. They surveyed 400 homes, right? If you look back, random was 400 households. It says it was a city, so 10%, 400 is less than 10% of all homes in a city. Okay, if it said it was like a small town, 400 might be too many, but good enough. Success failure. Oh wow, whole room's shaking. That's fun. Success failure condition. Yeah, they either have a smoke detector or don't. Working or do not. And finally, the large enough. Okay, large enough condition, so we have to do NP 400 times 0.2. Again, we're doing NP, not P hat, equals 80, which is greater than 10. And Q equals 400 times 0.8, which is 320, which is greater than 10. So those are all our conditions, which are exactly the conditions we had before for confidence interval. Nothing has changed. Well, it's that. See, the elf just fell. That's how much the room is shaking right now. Literally, I'm standing here watching things move. This is about a 3.5 to 4.0 earthquake right now in this room. I kid you not. Poor Alfie. Actually, I don't feel bad. You're a mess. All right. So we've got that. So, and we are able to proceed with and what's the name of this test? This is a one proportion Z test. Okay. At this point, they didn't state a level. Often we name it, because this is when we state our alpha level. Alpha is 0.05. When we name it is often when we actually state our alpha level. Just a convenient time to do that. Since none was specified. Okay, T, next you do the test statistic. Here's where we actually do our calculation. So, the calculator P hat, our P hat was 376 out of 400. And 376 out of 400. Where did I put my calculator? This is first hour. If this isn't first hour, I'd always know where my calculator is. I think I took it with me. Indeed, I did. Which is 0.94. Okay. My standard, now am I going to get a standard deviation here or a standard error? There's a good question. Are we going to run a standard deviation here or a standard error? And the way we answer that question comes down is, do I think I know what the actual real proportion is? Do I think I know the parameter, the population proportion? If I do, I'm going to use that and do a standard deviation. If I have no idea what the actual one is, then I'm going to use a standard error. So in this situation, do I think I know what the population proportion is? Yes, because I have P equals 0.8, so I'm going to use 0.8. Okay, so it's going to be PQ over N. So 0.8 times 0.2 over 400. And square root of that is actually exactly 0.02. How nice is that? Okay. So now that I have a mean and a standard deviation, I can do a z-score. So observed minus expected over standard deviation, which is 0.14, or 0.02, which is 7. Okay. I'm going to model this as part of this and draw a picture. Don't have to be super specific, but 0.8 is here. One standard deviation would be 0.82. Okay, we are way out here. Okay, two standard deviations is going to be 0.84. We are way out here. Finally, the probability, therefore, that we could probably say the probability that P hat is greater than or equal to 0.94, or the probability that Z is greater than 7 equals, and if you put this in your calculator, it's going to give you 0, I think. But let's go ahead and do this in our calculator real quick, just to practice. So we're going to go to Stat, Tests. This is going to be one proportion Z-test, number 5. My P0 is 0.8. My X was 376. My N is 400. I want to know, whoops, shoot, hit the wrong button. Sorry, I hit the wrong button and took myself right out of it. I want to know if it's greater than P0, and I'm going to calculate. And it gives me a p-value of 0.0000000000128. Okay? Gave me a z-score of 7. So if you look at your output, it actually tells you the z-score and the p-value, which is extremely small. Okay? 1.28 times 10 to the negative 12th power, which is essentially 0. So at this point we have, oh, by the way, this is my O, my obtained p-value right there. Now I need to make a decision. My p-value is obviously very, very, very small. Way less than any alpha would ever be. So are we going to reject the null, or are we going to fail to reject the null? Let's think about the words here, because the words will, if we think about the words, it's going to just tell us what to do. The null is nothing interesting is happening. This is an expected situation. Are we going to reject that assertion that nothing interesting is happening here? Oh yeah, we're going to reject that. We got lots of evidence. Something interesting is really happening here. So we are rejecting the null. Okay? So, and we will say a statement like this. At p-value equals 0 less than 0.05, which is my alpha, we reject the null. Okay? Or reject H. If you want to say reject H naught, that's okay. Summaries. There is evidence to suggest that. So when we reject, the conclusion is there is evidence. Not we have proven or we can show that. It's there is evidence to suggest. And what is it we're trying to suggest? Go back to the original question. Use the language directly from the prompt. That the local rate is higher than the national rate. And maybe I'm giving a little more context than that the local rate of working smoke detectors is higher than the national rate. So that's a full hypothesis test. They aren't short. They aren't quick answers. They aren't x equals 5, we're done. Okay? They take a while. But what Phantoms does is it helps make sure that we are covering all of our bases, that we aren't missing anything important. If you can deal with the Phantoms process, then you know you're covering everything that the graders are going to be looking for. Now you have to do it correctly too, obviously, but that helps. All right, so let's move on to day 2, which is simply going to be another example. Just have to slide it over. So let's do this again. Okay, there are supposed to be 20% orange M&Ms in a bag. And I get a bag of candy that has only 21 orange M&Ms. Do we think that is evidence to contradict the company's claim that there's 20%? Okay. Fair enough question. Let's go ahead and start our process. Let's write our hypothesis test. What are we testing? What is the parameter we're testing? How am I going to state this? Somebody give me a statement. You're going to have to say this out loud. The elf demands an answer. Somebody speak, or I will look at you. Come on, he's getting feisty. All right, then we randomly select, right? I shall randomly select somebody to do that. So I'm just numbering across the way I see you. So Taylor's 1, Ellie's 2, Nick F is 3, Abby's 4th, Nick N is 5, Ellie is 6, Grant is 7. I will have my calculator generate a random number between 1 and 7. Oh, number 1, Taylor, you get to go.
So I need to make that parameter?
So this is like your initial statement. What is it you're looking for? Basically you're restating the problem in your own words.
So I pose it as like a question or as a statement?
As a question.
Okay. Does the company have 20% of orange M&Ms in a bag?
Okay, that's essentially right, but let's ask it a little differently, okay? We usually will start like is, or is there evidence to say that it's not 20%? Okay, now in this case, is this going to be, are we asking for evidence that's greater than, less than, or just different than 20% according to the question that you see here? Just different than, yeah. Okay, just asking, is it different? So you're on the right track, but maybe we'd state this more like, is there evidence to suggest the proportion of orange M&Ms is not actually 20%. Okay? Something like that. Okay. So null hypothesis. So what's my null hypothesis going to be? And my next random number was 7. So Grant, you're up. What is my null hypothesis going to be? H naught is that?
Is this like what is it like when nothing interesting is happening?
Yes, null is nothing interesting. Null, 0, nothing.
Then that would be like the 20% of only orange M&Ms in a bag.
Okay, so how could I state that? P of orange.
P of orange equals 0.2.
0.2, yep. Okay. So alternative hypothesis, that was number 3, which is Nick F. Get you started, P orange.
Was this
So your big question is, this is greater than, less than, or just not equal to according to the question? Not according to the numbers. According to the question, is the question asking, is it more than, less than, or different than?
Different than.
Different than, so that's going to be a greater than, less than, or not equal to sign.
The not equal to.
Not equal to, okay? That means this is going to be a two-tailed test, which isn't going to affect us too much because our calculator is going to handle this, but it really is important. This sign right here, and the not equal to, is really important that we get that right. So you got to read it very carefully. An independence assumption, yes, each bag is an independent sample. Okay, random condition. Again, it's not stated that it's a randomly selected bag, but every bag is a random collection of M&Ms. Okay, not stated, but every bag is a random collection of M&Ms. That's reasonable. 10%, okay? How many M&Ms do we have? 122. Okay, success, failure. Yes, orange or not. Large enough, NP is 121 times 0.2. Which is 24.4, which is greater than 10. And Q equals 121 times 0.8, which is 96.8, which is greater than 10. So we can proceed with a one proportion z-test alpha equals, we're just going to use our 0.05 again. That part should be one of the easier parts because we're kind of used to doing those steps. Maybe naming it's a little bit different, but that's okay. Now we perform the test. So what's the first thing we're going to calculate? Here? P hat, yes. Okay. Our P hat was 21 out of 122. So 21 divided by 122 is 0.172. Okay? Am I going to use a standard deviation or a standard error? Do we think we know what the actual proportion is? Yes, because we have an H naught that says P equals 0.2. So we're going to use standard deviation. So standard deviation equals the square root of PQ over N. Square root of 0.2 times 0.8 over 121. So 0.2 times 0.8 divided by 121, square root is 0.0363. So now I can calculate a z-score equals 0.172 minus 0.20 divided by 0.0363 minus 0.2 divided by 0.0363 is negative 0.771. You can draw a little bit of model of this. So you always want to draw a picture. It's going to help us remember what's going on. My mean is at 0.2. Okay, my value here is at 0.17. But since it's a not equal to, I'm going to get both areas on both sides. That's what we're going to be adding up. Okay. Next, now that we've got all that, we're going to obtain our p-value. So p that how can we say this? That p hat is greater than, or is less than, sorry, or equal to 0.172. We're going to take 2 times that because it's two-tailed. We're going to do that in our calculator now. So stat, tests, 1 proportion z-test. P naught is 0.2. We had 21 out of 122. I want to know not equal to, calculate, and I get a z-score of notice it gives z-score of 0.769. Yeah, we had a little rounding error there, but that's fine. And my p hat, or my p-value, is 0.4415. Okay? Now we make a decision. I mean, it's pretty obvious. We were not less than 1 standard deviation from the mean. And we have to add up both sides. So are we going to reject H naught and say something interesting is happening here? Or we're going to fail to reject H naught and say that, nah, this is pretty much expected. This is within a normal range of variation. What are we going to do? Abby, you're the next one up. You have to make the choice. Reject or fail to reject?
Fail to reject.
You are correct, ma'am. With p-value 0.44 greater than 0.05, we fail to reject. H naught. So we make our decision. Summarize results. We fail to reject. It means there is not evidence. To suggest the proportion of orange M&Ms is different from point 0.2. Okay, so when we fail to reject, that means there is not evidence. When we reject, it means there is evidence. And we kind of use that same phrasing over and over again. There is not evidence or there is evidence. Those are our 2 choices. There is not evidence to suggest, there is evidence to suggest. The more you get used to using these same phrases over and over again, the better off you're going to be, because then you're not always searching for the right words, because you can kind of like, oh, yeah, I've kind of got this boilerplate. I've got this form that I keep filling out as to how to state this so I state it correctly. Like I say, one of the things I always see is people fail to reject and then they say there is evidence to suggest there's a difference. And so it really takes some time and thought to make sure you got that straight in your head. Rejecting means that there is evidence. Rejection is essentially almost a successful test. Okay? Failure to reject means nothing exciting. It's almost like an unsuccessful test. No evidence. Okay? Yeah, Taylor's internet's being really wonky. She keeps disappearing. But that's it. That's our whole example. Obviously, key in this process, being able to state your initial problem, being able to state your null alternative hypothesis. The assumptions and conditions, not so bad. You guys are used to that. And then being able to perform your test with formulas, use your calculator to find the value, and make your decision and state your solution. It's just, the more you do this, this is going to start to become real automatic. But at the beginning, it's awkward. But you will get used to it. Okay? So, looking forward. I think we're going to look forward here. I'm trying to look forward here. Looking at my wonderful calendar. On Monday, yeah, it's a homework discussion day. So Monday, we're just going to be going over homework problems and having any questions and answers and stuff like that. We'll be reviewing on Tuesday. We'll be taking an 1819 quiz on Wednesday. And then Thursday and Friday, we'll be doing chapter 20. The Monday, Tuesday stuff for the following week, basically that's all designed to be asynchronous. I do have a homework discussion day scheduled for the 22nd, but it's going to be asynchronous, so it'll be you emailing me questions on the 22nd, and then I will be responding to emails. We're setting up individual Google Meets if there are questions. In other words, wink, wink, nod, nod. If you don't have any questions, you don't have to do anything that day, right? We're having asynchronous class. So you get the idea. But if you do have questions, by all means, I'm going to be here. Okay, I'm working. So by all means, between the hours of 7:15 and 3 o'clock, email away. I am here for you. Okay? After 3 o'clock on the 22nd, yeah, don't talk to me until we come back. I love you all, but no.
Same goes to us, I think.
Fine. Works for me. Little being with your family time. So if you crave your family's attention, right, Ellie? And by the way, I expect all of you to come and listen to Ellie be a wonderful Miss Brooks on the radio drama that we're doing on Thursday, Friday, and Saturday night next week. So I'm doing on YouTube Live. Okay? I'll try to post links and stuff like that in student announcements, but I'm also going to, it's also already on the Facebook page for Milton High School Drama. The links are there, and they're in the Courier. So come see Ellie. It's great because you can just turn it on and you can work on something else while you're listening to people telling you stories. It'll be fun. It's like radio drama. Yay! All right, well, that's all I have for today. Have a wonderful weekend. Think snow, think cold, think snow. Maybe we'll get some snow. Make it look like Christmas. Keep the elf happy. Okay. Elfie and I say, bye-bye. That's kind of creepy, isn't it? It's really creepy. Bye-bye. I'll be visiting your house soon. It's the most interesting video ever.